Greetings everyone, this tutorial is about how to use ribbon rake to do a bendy arm. The first thing you want to do is just go create a NURBS plane, and then theoretically speaking you can actually put it anywhere, it will work. But just for it to be easier to understand, let's just move it above the arm and maybe rotate it forward 90 degrees, and then let's go to the inputs and make the width really high, so it kind of like having the same length as the arm. And then you want to give it a lot of patches on the U direction, like that amount, and then the length ratio can be lower. Okay. And then you can delete history on it, and that should be the ribbon. And then let's go name it NURBS left arm ribbon. Alright, now the next step will be creating the hairs. So let's go to FX and hair, create hair. What you want to use is the default setting and change the U count to 16 and V count to 1. That will do 16 hair systems along the U direction, which is the length, and only one on the V direction. So you will only see one row of hairs. And then you want to change the dynamic to static and then create hair. And when the hair is created, you then need to go grab the PFX hair and delete it. You don't need the hair system and nucleus either, but you need this hair system follicles. Let's open this entire hierarchy, and then you want to go delete those curve folder, a curve group underneath it. You see they're empty, so they're not really doing anything. But the follicle will actually follow the deformation of this NURBS. So now if I drag this up and down, you see the follicle is now following it, which is what we want. Alright. Now the next step will be creating joints. Okay, what you want to do is just create a joint anywhere. Okay, and then you want to use the follicle to parent constrain the joint. So follicle first and then the joint to constrain, which is underneath rigging, constrain, and then parent constrain. That way it will snap the joint there. If yours is not snapping, you may want to check your parent constraint, make sure you don't have maintain offset on. Alright, but this is repetitive stuff, and I also want to rename those follicles, so let's do some coding to make that work better for us. Let's do a new Python tab. What you want to start with is first import my CMDs as MC, Maya command. You can name this anything. Some people name this uppercase MC or CM or CMD as I'm just gonna use MC. And then you want to define a variable called selection will equals to MC dot list selected equals true. So this will list all the selection you have. In this case, our selection will be the follicles. Okay. And then what you want to do is do a for loop for atom in selection. Let's just try print their name and make sure our loop works. Now if you do the command, it will print all the names. And of course I'm not changing their name, right? So I'm not just printing their name. What I want to do is change their name. So for index, you can name this variable here anything. The reason I would name it index is because it's an index. So for index, it's a number in a range from 0 to the length of the selection. Let's see what that index is. If we print index, see now it's printing numbers from 0 to 15. The index will be incrementing every time we loop back to a new loop, and it will be start with 0 and go all the way to the length of the selection. The length of the selection, which is this one, is the number of atoms inside of this selection container. Okay, so print index will be the number, and I want to make something from this index. This something will be the suffix that will be used later on for my name. So suffix equals stringify our index. That just makes the index into a string. Okay, and then put in the .z file that will actually give it some number padding. So now if you run the code, oops, let's print the suffix. You will see the number from 00 all the way to 15. We have this name padding with 1 0 in front of those numbers, but it will not add 0 if you have 2 digits already. Anyway, so of course I need not from 00, I want it to be from 01 to 16, right? So I just need to put in +1 after index. That way I will get Maya to print 01 all the way to 60. Okay, now the new follicle name. New follicle name will be equals to the first of all, I want to name it to start with follicle, and then we will plus something, and that's something we can actually ask the user to define. So name base will equals to raw input from the user, okay, which is this one, and we just need to use follicle to plus our name base, and then plus a underscore, of course, and then plus our suffix. Okay, just making sure it is correct, we can try to print it. Follicle name, and it will ask you, let's try GG. It's gonna print follicle GG, which is this name base that is added into the new name. So follicle underscore GG underscore suffix, which is the number. And let's then go rename it. So what I'm gonna do is MC dot rename, and it's gonna rename the selection with the index of current index we're looping. It's gonna just this entire thing means the follicle, and then we'll name this follicle to a new name, which is the follicle name we defined. Okay, now if you run this code, and let's try left arm or ribbon, what we'll do is just rename it properly, follicle left arm ribbon something. Okay, fantastic. Now let's go create some joints. MC dot joint. Before I do that, you may want to clean your selections. MC dot select cancel equals true. Okay, we're not selecting anything, and then you can do the MC dot joint. Otherwise, this command, this joint command, will give you some weird arrow. I don't know what that is. Just doesn't really care, but you know, seems like deselect fix that problem anyways. So we're gonna create a new joint. It's better to just give it a variable for that. So new joint will be equals to mc.joint, and then the name will be the jt underscore and plus our name base, and then plus underscore and plus a suffix. Alright. And then after creating the new joint, what we want to do is do parent constraint to snap the joint to the follicle. It's very easy to do. mc.parent constraint, and we're using the follicle. Can use the follicle name, and then the follicle will be constraining the new joint, and that should be it. Let's try that. Arm ribbon, and then oops, I got an error. Suffix is not defined. Suffix is uppercase. You know, some habit I have. Anyway, left arm ribbon. Oops, I didn't select anything. Let's try that again. Left arm ribbon. It will work. Now I have those joints, and I don't need to see the follicles anymore. What you can see now is that when you drag the surface, everything moves, because when you drag the surface, the follicles here will follow. And because the follicle follows, and the follicle is having parent constraint on the joints, of course the joints will be following. Just for organization purpose, I'm just gonna group the joints, and then name this group, you know, JT left arm ribbon GRP. And then the other one, the follicle group, will be named a follicle left arm ribbon GRP. So we have a joint group and a follicle group. Alright, fantastic. Now we don't need to see the script editor anymore. So let me go delete it. Now it's time to start creating controllers. So let's go to create nervous primitive circle. Okay, this is going to be AC left arm or ribbon shoulder. Okay, and then of course we need a group, and that group will be the same name with underscore GRP. Now one thing you want to make sure this joint have is that its X, Y, and Z direction is pretty much aligned with the shoulder joints. What I mean by that is if you go show the shoulder joints, and let's go select it and go display, transform display local rotation axis, you will see its axis going downwards or lower hierarchy. Y is up, Z is forward. You want to make sure your controller is pretty much the same thing. So X is facing that way, at Y is up, Z is forward. Okay, if that's true, then all you have to do is go holding down the V button and snap the group of the controller to the first joint there. Okay, and then you want to scale it up and then rotate it scale the vertex up and rotate it. You don't want to scale it itself because you want to maintain that orientation instead of otherwise when you were matching them back together later on, you're gonna have some twisting. Alright, so I have a controller now. I need another joint underneath it, so let's go just duplicate this one here, and let's make the radius bigger, and let's name this new joint JT left arm ribbon shoulder band. Okay, and then this one will be parented to the controller. Alright, now we have a joint underneath our new controller now, and that parent constraint was duplicated from the original joint, because those joints here have parent constraint underneath those, but I don't really need this one, so let me just go delete it. Alright, let's go duplicate this shoulder controller and holding down V to snap it to the last one. Okay, this one will be the wrist. Alright, now let's duplicate this group again and drag it back. I wanted this one to be in the middle. One of the ways you can do is select those two controllers on the two ends, and then control select that new group we duplicated and do a constraint point constraint. That way it will snap it right in the middle. And after that, you can then go ahead and delete the point constraint. This controller in the middle, of course, will be called the elbow controller. Okay. So essentially what we have is 3 controllers. Okay, one for shoulder, another one for the wrist, and another one for the elbow. The elbow is right in the middle between shoulder and the wrist. Okay. And then what you want to do is select those, select our the elbow group, and then group it. And let's name this new group elbow follow group. Now this follow group will make the elbow controller follow those two controllers on the two ends. To do so, you just need to grab those two controllers. Okay, and then control select this follow group we just created. Let's do a constraint, point constraint. Oh, if it pops, that just means that this new group's pivot is at the origin. So you just need to go to a modify center pivot. That way it will work. So let's try that again. Those two controllers, and then control select the follow group, the constraint, point constraint. That way when you drag this one up, you see that one follows, right? If you drag the other one up, you see this one also follows, because they all have weightings on this point constraint. And they should be the same because this one is supposed to be right in the middle between those two controllers. Alright. Now of course I need other controllers in the middle. So let me go grab this elbow group. Okay, this one, and duplicate it 4 times. Okay, let's grab those two and drag them forward and backward, and the other two. And just distribute those new controllers across the ribbon. And you want to start renaming them. There are actually secondary controls. So I'm just gonna call this one secondary 01. Okay. And you want to rename that. And the joints will be renamed JT, left arm secondary band 01. Okay. And you want to keep renaming those. I think I can actually reduplicate it, so that makes the renaming easier. Huh. So all I have to do is modify search and replace name. Search for 01, replace with 02. Apply. And this one will be 01 to 03. Apply. And that one will be 01 to 04. Apply. And we got everything. Alright. Now those controllers will also follow when you drag things around, because they're all underneath this follow group we created earlier. But what I really want is when I drag this up, I want those to be followed. So when I drag this up, those 4 controllers are on a single straight line. The same thing will be happening on the other side. To do so, the first step you want to do is you want to go grab this controller in the middle, and then the wrist controller, and then control select the secondary 03 here. And then what you want to do is a constraint, point constraint, and you want to change the elbow's weight to 2 to move it back to here. Okay, and then you want to Do the same thing for the group of this controller here, which is secondary 04, another point constraint, and go give the wrist the weight of 2. What that does is, now if you drag this one, you see the those 4 controller will be stay on the same straight line, and the same thing happens when you drag this one up too. Okay, which is cool. So let's do the same thing on the other side. So those 2 controllers first, and then the group of those one of those secondary controller and a point constraint. And then you just want to change the weight to make it favor to one part or another. Let me do the last one here. After that, you should be seeing the nice linear transition, so they'll always be kept into straight lines. Alright, now one last thing is that when I drag this middle controller up, I want that controller to be actually facing excuse me to be actually oriented, or changing its direction. Excuse me. So to do so, all you have to do is a aim constraint on it. So what you want to do is select the controller and select the controller in the middle, okay, and then select the group of the secondary controller and do a constraint, aim constraint. Now for those controllers, because their X direction is facing there, so you actually want to use -1 to do the aim constraint. Okay, let's do the same thing on the another one. But for those ones, for that one, before it, you see the X is actually facing forward, so you want to use 1. That way when I drag it, you see they're always kept into a straight line, which is nice, and also oriented to the right direction. Don't worry about that, that's gonna be okay. Alright. Now when that is done, all you have to do is grab the bigger joints here, the joints that are underneath the controller and the ribbon geometry. You want to just go for a skin band skin, and a default setting will be good. So that way when you drag the controller, you see you're deforming the ribbon here, which is cool. Alright, now to actually attach our ribbon to the shoulder, to the arm, what you want to do is select the shoulder joint and then the group of the shoulder AC controller and do a constraint, parent constraint. That will snap this one there. Select the wrist and then the wrist group, constraint, parent constraint. For the middle one, it's a little bit trickier. You want to go grab the first group, the top group, sorry, the direct parent group of the controller, not the follow group, okay, the direct top group. You want to use the elbow joint to do a parent constraint on that group. Okay, that will snap it there. And when that is done, and when you drag the arm, you see the ribbon rig now is following. I don't know why it's moving weirdly. It's now following the arm. It will follow both IK and FK because what we're using is the bending joint, so they will follow IK and FK all together. Alright, now to actually make the controllers work, they're not working now. What you need to do is actually using those joints here underneath the joint group. You want to use those to band with the skin, so it would be better to have band there in their name. So let's go modify, search and replace name. So let's change the _0, search for _0 to band _0. Okay, when you do that, I will have band there. Oh, sorry. I cannot do underscore 0 because it's let's change our ribbon to ribbon underscore band underscore, and oh, just ribbon underscore band. That will name them correctly. Actually, I'm lost in AI here. All right, now you want to select those joints and then the skin, and let's go to the skin, edit influence and add influence. Okay, you want to check out lock weights, that way you will not destroy the weighting you have before. And then let's go to paint skin weighting too, and then you want to go through the list, and you will see the last joints here will be the new joints we added in, 16 joints in total. Okay, so it's gonna take you a little while to have their weighting, because we're implementing it on the already rigged model. So if you're rigging it from the very beginning and you already have this idea of, you know, I'm gonna implement the ribbon rig on the Bendy Arm, then you probably will never actually have the original binding joints here to rig with the joints, so their naming will be actually changed to we're gonna get rid of this band to just underscore. Okay, oh, actually just band to nothing. I cannot do nothing. Okay, underscore band to underscore. All right, they are now driver joints. Anyway, so let's keep the skin weighting. This is gonna take you a little while to do some tweaking. If it's hardly that easy to make everything work at the first try. You will have some floating areas that does have some weighting still from those bending joints before. It's not that easy to, you know, paint because there are a lot of joints. Okay, 02. I think I'm eliminating all 02 by dragging by painting 03. What you want to do is go back and forth, making sure you're taking care of all the area here. 1, 2, 3. Let's go on to 4. It's gonna take maybe that line. You want to give it a value of 1 and then just overwrite the weighting here, because you know that if you don't, then those weighting will be still belongs to the original bending joints, which is not good. Alright, just keep going. 5, 6, 7. Alright, and then 8 would be this little one here. I guess it's actually quite dense, so I may not need that much of a joints, maybe 8 joints or 10 joints instead of 16, because I barely have enough edge loop to do that. 6, okay. 6 is here, 7, 8, and 9. This little part, 8. Okay. 7, 8, 9. All right. 10. So yes, you need to be a bit patient to use this setup. So, 11. C10 is that, 11 is it. Okay, and then 12. You see, it's actually easier to paint this kind of weight on those parallel loops, but it's really hard to do for this kind of geometry because you have this diamond shape. But so when you're modeling, it would be better to just make the geometry simple as long as it can represent the shape. You don't want all those. Don't want to try to always represent the anatomy muscle structure underneath it. One of the reasons is because it's actually making the weighting harder, making the final shape harder to be rigged. So parallel loops is good enough most of the times. I guess what I'm saying is don't try to do fancy topology if you are not really need that. The topology on the face are needed because they need very complex animation, so that's needed. But other than that, I think for the hand and the arm or the torso and things, just think of them as cylinders and just make them as close as a cylinder topology, and you should be good enough. Alright, so one thing I want to mention here is that you don't want to mess with the last joint here, the band 16, because that joint is overlapping with the wrist, and you want the wrist joint, the original banding joint, to take care of that. So now if you look at the weighting, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 16, and they all have controlled a little portion of this entire arm. Okay, once you can do after the first pass, you can go for smooth and then flat to even out your weighting. It looks like that one doesn't really have much. Okay, let me give it some. Okay, so 3, 2. Oh. It's always good to make them nice and smooth. One. Okay. Oops. Smooth. Okay. So 1, 2, 3, 4. It's taking so little. Let's take a little while to tweak. If you want it to be perfect. Okay. Smooth 5 doesn't really do anything. 5, 4, 3, 4, 3, 2, 1, 2, 3, 4. Can give 4 a little bit more here in the middle. 5, 6. 7. 8. 9. I think 9 can have more here on this. Maybe not that much there. Okay, so that's 9. 10. 11. Seems like I'm pushing the weighting around. Okay, 11, 12. I'll give it some more here. Smooth it. 13. Guess it's okay. 14. Something like this. And then 15. Okay. Just go through it one more pass, making sure it's all nice and smooth. And of course, you can only see if it's working by trying to drag the controller. Okay. Of course, there is something wrong down there. Okay. One of the things you can try is go to the list and find the shoulder one, making sure it's not having all the weighting here. You can use subtraction now. The reason you can use subtraction is because you know that when you subtract those things, they're going to be evenly distributed, not even, but proportionally distributed to those joints around it, because they are the only joint that does have weighting over there. Okay. Alright, let's keep fixing the weighting. It's going to take a little while. 2, 3, 4. 4, 5, 6. Now the tricky part will be the middle one, because it's really doing something weird. Let's check it up. Skin weighting. Let's see, the 8 should have more control here, and then smooth. 9. Smooth this out. 10. All right. Okay, I'm not sure what's happening there. Maybe that's because that joint is having something, or let's see, this one, that one. I think I have more control over there. 13. Smooth that out. Alright. So that's basically the basic stuff about ribbon rake. Okay, now you can use the controller to drag them around to really bend the arm in whatever way you want. Now there is a little thing you may want to tweak, which is every joint here lives on the ribbon, right? If the ribbon is not having a proper weighting, then their movement will be weird too. So you may want to actually give them proper weighting too, if they're not proper. Maybe that one can have more there. Let's see. Smooth that out. All right. Okay, so that's the basic of ribbon rake for the arm. Now there are more things you can do with it. Oops, it looks like they're all going to a weird position for some reason. Oh, because I pinned the weighting. So it would be better to pen the weighting earlier than later, because that way you're changing the location of the joint, so that's not good. Let me go back. Otherwise I have to reband it, which is not cool. So alright, anyway, so let's do the final organization then. We have the ribbon, right? Let's just group that, and let's call it nervous left arm or ribbon GRP. And we have the controllers, so 3 ACs, group them together, AC left arm or ribbon GRP. And then we have joint and follicle. For follicle and the nervous, let's group them together, let's call that other element left arm ribbon GRP. Okay, now group them together, that's gonna be the left arm ribbon rig. That group of course will be underneath the arm rig, okay, to put it back to the hierarchy. Now if you try to move the global controller, you see you have double transformation, and to fix that is very easy. All you have to do is go to the ribbon rig and then find the other elements. What you want to do is uncheck its inherent transform, and then everything will move just fine, including the scale. Alright, so of course you can clean it up by hiding the joints, and including those ones of course. And then you can have a controller to control, do you want to see those secondary control or not. So we can go create or give it a new attribute. Let's call it secondary control, okay, 0 to 1, and that one will be controlling the visibility of the AC group. Okay, so we can turn it on and off using our slider. Alright, and of course some color coding would be nice, so you can select the top node and go to display, drawing override, enable override, you can give it some kind of pink color. Alright, cool. Now we have a working bendy arm now. If you want to give it more functionality like the wave I showed you in class, that's also easy. And so what you want to do is go find the oh, by the way, it will work with stretching. Well, we cannot see it here, but you can definitely stretching, it will work here. Right? We don't have stretching implementation here, so I cannot do that, but just so you know that stretching will be automatically done if you use this setup. Anyway, let's examine some of the things we can do with it, like the wave. What you need to do is just give it a blend strip. And let's call it left arm ribbon blend strip, and then give it a new target. Let's call this one wave. Alright, and then right click on it and rebuild target. That will rebuild one right here, which is its original location. Now what you want to do is give it a deformer, nonlinear, and then sine deformer, and then rotate it this way to match this line with that geometry. And then you can use the line to the deformer to deform the arm. Of course I want it to be the other way. Alright, so now if you do the amplitude, you can wave it. You want to turn the drop up all the way to 1, so it's not gonna change the start and the end. You can use the offset to make a wave like this. And of course, to put those back into hierarchy, they're just gonna belong to the other elements. Okay, and everything will be fine. And if you just want to control it, it's very simple. You just need to use some attribute to control the sign, right? So you can add a new attribute here on this controller, and then connect it to the values here, like amplitude and wavelengths and all sorts of stuff. I'm not gonna do that because I believe you can figure that out yourself. The wavelength is like how much wave there is. You know, it's better for things like snake. I don't think it's useful here though. But of course it will work with the ARM other functionalities, right? So don't worry about that. One more thing I think is worth mentioning is the twisting. So let me zero out the sun thing. So you need a twisting here, right? Because when you rotate it, it's not really twisting. Of course you can manually just twist it. I think that's actually quite easy to do. But if you wanted it to be automatic, what you can do is you can use the joint, the first joint here and then the elbow joint, those two joints, and then you want to do parent constraint on the controllers group. So those two controllers, let's give them a new group. It's called it's twist. Okay, now the other one will also be grouped with a twist group. And what you want to do is use the first joint, the wrist joint, and then the elbow joint, and you want to do the orient constraint on it. Okay. Let's check out maintain offset. And of course you want to only use the x-axis, the other axes are not needed. Okay, let's do the same thing here from the first joint, the wrist joint, and then the elbow, and do another constraint. And of course the weighting will be for this one, 031, the elbow will have 2 weight, and then for the other one it will have the wrist will have 2 weight. Okay, and I guess that is it. And now if you do that, you will have twisting on the forearm. It's not quite perfect. Sometimes it will break in the middle, but you know, no one is going to twist it that way. Anyways, if you really want to have a decent, you know, like an overall twist, of course what you can do is you can give the ribbon a actual twist blend shape. Just like how we do the wave, you can give it a new twist control. Okay. Oops. And then you can rebuild the target, and that one you can apply another deformer, which is the twist deformer here. Alright, so if you really want to twist it, you can use this to twist it. It's gonna twist it entirely. Okay, so let's say if you have the arm go this way, you want it to really twist it, you can use this. Of course you can have a controller to control this. You can even control the twisting area of this arm, so you can have all those attributes to be connected to help you to make the twisting better. Alright, but I'm not gonna go over all those things. I think you will be able to figure that out yourself. Anyway, well, after you have this, you just need to parent it underneath the other elements, and it will be just fine. Let me zero out the twist I did. So that is it. That's the Bendy Arm. And there are other setups that look similar. I can show you that by opening another file here. Okay, so I have another rig I did before, which is the same character but rigged a little differently. This rig also have the secondary control, okay, and it does seems like working the same way, right? But if you go into the hierarchy and see what they are, you see that the joint is actually the underlying structure is not ribbon, it's actually the Aki spline. Okay, so you see the Aki handle and all the joints. It's the Aki joint chain instead, and I actually can do similar thing. So ribbon rig is not the only way, and but the reason I teach you the ribbon rig this class is because the Aki spline setup is something you already know. So if you're curious on how to implement that on the ARM, I believe you can figure it out by yourself. But if you can't, you can also find some tutorials. But anyway, this setup, the primary ways of doing this is something we already taught. So anyway, and that should be this tutorial. Okay, and feel free to use this kind of setup, and of course if you don't need it, you don't really have to do that, because you know, doing production is time consuming. You don't want to do the things you don't really need. That Bendy Arm is, in my opinion, not really that useful. But ribbon rig is really useful when you're doing things like snake. So I'm sure it will be useful sometimes. So thanks for watching and see you next time.